In this question, we're told that three numbers are consecutive terms in an arithmetic sequence. Their sum is 48 and their product is 2,800, and we're asked to find the three numbers. So let's begin with what we're told at the start. Three numbers are consecutive, that's very important, terms in an arithmetic sequence. That's another very important thing. So consecutive terms means we're dealing with un minus 1, un, and un plus 1. Now I chose n minus 1 and n plus 1 and un, these three consecutive terms, for a particular reason. We could have chosen other ones. We could have gone with un plus 1 and un plus 2, but for reasons we'll see in a second, that one doesn't pan out as nicely. What this means, because we're dealing with an arithmetic sequence, is that compared to un, this is un minus 1 is going to be un minus d, un, and then un plus d, because it's an arithmetic sequence. What we're told about these is we're told that the sum is equal to 48. So if we do un minus d plus un plus un plus d, we know that that is equal to 48. And this is where this version falls apart a little bit, because if you imagine adding these ones, we'd end up with something slightly different. Now the benefit of doing it this way is that when you simplify this left hand side, this minus d and plus d cancel out. So we just get left with 3un is equal to 48, which we can solve to find un is equal to 16. That is, the middle term is equal to 16. Going along with this route, you would have ended up with some d's still in there, which makes it a little bit more complicated to solve. Not impossible, you can use simultaneous equations, but a little bit more complicated. The next thing we're told is their product is 2,800. So that means that un minus d times un plus d is equal to 2,800. But we now know that un is 16. So this is actually 16 minus d times 16 plus d is equal to 2,800. This is an equation with just d in it. The easiest thing to do first would be to divide through by 16. So we get 16 minus d times 16 plus d is equal to 175 when we divide by 16. And then this is a difference of two squares, which we can expand to get 16 squared, which is 256, minus d squared is equal to 175. Rearranging this, we get d squared, that's d squared there, not d2, let me make that a bit clearer. D squared is equal to 81, which means that d is equal to plus or minus 9. Don't forget the minus 9 there as well. With our value of d and our value of un, we can now go back and find out what the other terms are. The terms are either 16 minus 9, so that would be 7, then 16 plus 9, which is 25, or we still have a middle number of 16, but it would be 16 minus negative 9, which is 25, and then 16 plus negative 9, which is 7. In either case, we get the same three numbers, just in a different order. But the numbers, which is what we're being asked to find, are 7, 16, and 25 in one of those two orders. Here we've used a few things. We've used the fact that it's arithmetic to write three consecutive terms in terms of one of the terms. And then we've used essentially simultaneous equations, but we've managed to cancel one of them down to find un first, to find d, and then substitute in to find the values that we need.